Hello, starting chapter 3, section 3.1. We're going to cover it in two lessons, today and on Wednesday. Okay, first thing that you need to get down is the difference between explanatory variables and response variables. From algebra and pre-calc, you guys are used to thinking about those as inputs and outputs. Okay, explanatory variables are like an input. It explains the change in the other variable. Like the inputs, it will always be graphed on the x-axis. Response variables are like the output. Okay, they measure some outcome. It's what the equation spits out. And it's always graphed on the y-axis. In some situations, there will be a clear explanatory response relationship. The more homework you do, the better your test grades. Okay? The explanatory variable, the input, is the homework. The output is the test grades. In other cases, it may not be a clear explanatory response relationship. For example, there's a strong correlation between SAT math and SAT verbal scores, but there's no clear explanatory response relationship. You can't say that one leads to the other any more than if you flip them around the other direction. So in that case, you could put whichever one you wanted on the X and on the Y. Doesn't matter. All right. You guys have kind of gotten the gist of me I like to ask you questions about interpreting things. Okay, that will apply here also, and I will ask you to interpret scatter plots. And when I do that, there are three things that I want you to address always, and one thing if it applies. Okay, you always need to talk to me about direction. Okay, is it positive or negative? And that positive or negative direction is the same rules that you had in Algebra 1 when you were talking about slope of the line. Is the line going uphill? Is the line going downhill? Okay, positive or negative, same as the slope. Okay, form. Okay, is the data linear? Is it quadratic? In other words, does it make a parabola? Is it exponential? Is it logarithmic? Okay, if you were to draw a rough line of best fit, and I used the word line totally incorrectly, or the parabola best fit, the curve of best fit, which one of those parent functions would most closely resemble the data? All right, strength you're looking at, is it a strong relationship? Are they all bunched really tightly around that line or that parabola? Or is it moderate? I can tell right away that it's a line or it's a parabola, but there's some spread, some scatter to them. Or is it weak? Meaning that they kind of look like a blob. Okay, if there are any outliers, you should talk about that when you interpret the scatter plot. Outliers will be obvious, I hope. They are data points, again, that fall outside the normal pattern of the graph. Outliers can be, you can have an outlier in either the X or the Y direction, or both. Okay, at this point, it's not necessary to attach any meaning to that other than saying it's an outlier. And we'll talk more about X direction versus Y direction outliers in another lesson. All right, yeah, you can probably hear me drawing dots on the board in that microphone. I'm sorry, that's got to be really annoying. All right, so let's say we have scatter plots that look like this, okay? both a positive relationship, both linear, and just because I like to hedge my bets, I'm going to say that the strength of the relationship is moderately strong. So if you were to have a random point that was, say, here, all right, the x-coordinate of that point is not out of sync with the x-coordinates of the rest of these points. It's just way high compared to the rest of them that have similar x-coordinates. So that would be an outlier in the y direction. If you had a point that was hanging way over here, okay, that would be an outlier in the x direction. We would expect data points, the red dots, that have similar x values to that blue dot. We would expect them to be a lot higher than this guy. So this is an x direction. Sorry, not y value. X direction outlier. Too far that away. All right, so if there's an outlier, you should make note of that, but that's all you have to do with it at this point in the game. All right, so we are going to get some data in our calculator so we can look at some scatter plots. Okay, you do not need to put in the years. Make a list of boat registrations and a list of the number of manatees that were killed that year by boats. And yes, we can pause the video while you all do that. Okay, so again, you don't need years, just boats and manatees. Chunk them in your calculator. All right, so assuming that you all have that in your calculator now, the next thing we're going to do is make a scatter plot. So you want to get a new page. Sorry. Get a new page, data and statistics. Okay. Boat registrations, manatees. At this point, you need to think about, all right, which one's explanatory and which one's response. In case you're not aware, boats kill manatees. The little boat propellers chop the manatees and it kills them. So we're going to say that the number of boat registrations explains the number of manatees that are killed by boats. So the manatees is going to go on the Y and boat registrations is going to go on the X. There's your scatter plot. Okay, I'm going to grab that and put it in the smartboard so that we can, or so that I can write on it. Alright, so if we're going to describe this scatter plot, okay, we need to talk about strength, direction, and form. Alright, so form, okay, hopefully we're all in agreement that that is pretty linear. It is positive, which in the context of the problem means that as the number of boat registrations goes up, the number of manatees killed goes up as well. They're both increasing, not necessarily at the same rate, but they're both increasing. And as far as strength, it's pretty strong. I would probably go with the moderately strong again. Whoops, sorry. All right, so we've got the data in your calculator. We made a scatter plot of the data. We described it. That's it for today. You all have got problems you can work on your homework, and you have the rest of the period to do that. Bye.